application problems for arithmetic sequences and series. So in this first example, Keisha devised a week-long study plan to prepare for finals. On the first day, she plans to study for 75 minutes, and each successive day, she will increase her study time by 45 minutes. How many hours will Keisha have studied after 1 week? So start off by just making a list of the numbers. Now notice that we're talking about how many hours in the week. So we're looking at, we're going to be looking at a series or a summation because we want to know the total for the week. So she's starting with 75 minutes the first day. And then it says the next day she's going to add 45 minutes to her study time. So 75 plus 45 would be 120. And then the next day, she's going to add another 45 minutes. And so that means she would study for 165 minutes. And I know you guys are thinking, what? How could she study that long? Just wait till you're in college. So we're going to continue this for 7 days. And you could actually just add 45 until you get to the 7th day and then add them all up. Obviously, you can do that. And it wouldn't be that hard. And honestly, on a problem like this, I might do it that way. But I want to show you the way to use our formulas for arithmetic series. So when you take a look at your formulas for arithmetic series, you'll notice that you have 2 different formulas. One of them we used if we knew a sub 1 and a sub n. Well, we don't know the last term, so we don't want to use that one. So we're going to use the formula that says s sub n equals a sub 1. Oops, I'm looking at the wrong one, sorry. So we want s sub n equals n over 2, and then we have 2 times a sub 1 plus n minus 1 times d. Now, we know a sub 1 is 75. We know d, the common difference, is 45, and we know n, assuming a 7-day week, then we're going to have n equals 7. I guess if you were assuming just a 5-day, Monday through Friday, take the weekend off kind of week, then you'll be in for a rude awakening when you get to college because you'll find you have to study on the weekends. Anyway, so we're going to go with n equals 7. So if we substitute the values that we know, so we have s sub 7 because that's the value that we're going to find. So we're going to put 7 over 2, 2 times 75 since that's a sub 1, plus n minus 1 would be 6 times our common difference is 45. And then you could grab your calculator. And when you evaluate that, we end up with, oh, my calculator disappeared. So we get 1,470. Now keep in mind, we were dealing with minutes. So we have minutes, but the question was how many hours. So keeping in mind that 60 minutes is 1 hour. Now notice when you do unit analysis, a good little chance to talk about this, I put the 60 minutes on the bottom because I need the minutes to cancel and my answer to be in hours. So those of you who maybe have trouble sometimes knowing which way to put the units cancel like fractions. So you just set up your unit conversion. So we take 1,470 divide by 60 and we get 24.5 hours. So over that course of time, she would have studied in 1 week 24.5 hours. That's like a day. That's a lot. Okay, for the next problem we're going to do, this one actually comes from your textbook. If you, for any reason, needed to look along there, you could. So on this problem, we're told a man gets a job with a salary of $30,000 a year. Okay, here's all my emails there. Going on here. So he gets $30,000. He's promised a $2,300 raise each subsequent year. Find his total earnings for a 10-year period. So what we know from this problem is that means the first year he's going to get $30,000. And then the second year he's going to get $2,300 raise. So he's going to get $32,300. And then that's going to continue for a total of at least for 10 years. So we're going to see what happens there. So what do we know? We know that our initial term is $30,000. We know our common difference is $2,300, and we're talking about the first 10 years, so we know n is 10. Now, if we could go through and figure out how much money it would be in the 10th year, so that we would know the first and the but we don't have to. We want to know the total earnings for that 10-year period. So again, we're going to use the same formula that we did before. S sub n equals n over 2 times a sub 1 plus n minus 1 times d. So when you substitute the numbers in, n is 10, so we get 10 halves. 2 times 30,000 is 60,000, plus n minus 1 would be 9 times 2,300. And then we can check this out. So 10 divided by 2 is 5, so we're going to get 5 times 60,000 plus 9 times 2,300. And we get a total of $403,500. Now you might look at that and say, well, do you think that's going to continue? Like, is he going to continue? And you could figure out how much would he get on the 10th year, just that year. This is the total, this is the sum for all the years. And then you could think, is this reasonable? Would an employer really do that and offer you that much more money every year? Would it happen indefinitely? If so, how much would they make at the end of their 30th year? So those are a lot of different questions that you could ask with something like this, and and explore that. But this is what we were asked to do, and this is what we got for our answer. On the next problem, also on that same page in your textbook, this is about theater seating, and it says an architect designs a theater with 15 seats in the first row, 18 seats in the second row, 21 in the third, and so on. So here is our sequence, and this would be an arithmetic sequence, and you can tell because it goes up by 3 each times. So we have a sub 1 equals 15. We have n equals, d equals 3. And the theater is to have a seating capacity of 870. And so we have to figure out how many rows. So we don't know n, but we know S sub n is 870. So notice I said this is an arithmetic sequence because this is 15 seats in the first row, 18 seats in the second row, 21 in the third row. That's an arithmetic sequence. However, we're asked to find something in regards to an arithmetic series. So I'm going to use a formula for this, and I need a formula that involves, notice we don't know a sub n. So I'm going to use the same formula that we used before. So we have S sub n equals n over 2 times a sub 1 plus n minus 1 times d. And then we're going to plug in what we know. So we know S sub n this time is 870. We don't know n. We know a sub 1 is 15, so 2 times 15 is 30. We don't know n minus 1. We know d is 3. So I have to solve this equation for n. Now what I'm going to do first is multiply both sides by 2 just so I can get rid of the fraction. So 870 times 2 is 1740. And now we have n times 30 plus, I'm going to distribute this 3, and we get 3n minus 3. So then that means I have 1740 equals n times, I'm going to put this in 3n plus 27. So 1740 equals 3n squared plus 27n. And I'm just going to arrange this because notice it's a quadratic equation. So we're going to have 3n squared plus 27n. Then I'm going to subtract the 1740 equals 0. So we have to solve this quadratic equation. Now, you can quickly check that 3 will divide into 1,740. Divisibility rules, add the digits. 1 plus 7 plus 4 is 12. Since 3 goes into 12, 3 goes into 1740. So I'm going to factor out a 3. So we have 580. Okay, now I would do a diamond problem next. So you might look at this and go, well, how in the world would you ever pick out the numbers, two numbers that multiply to negative 580 and notice that one's negative, one's positive. So the difference between the two numbers has to be 9. Well, here's a trick I do because the numbers are fairly close together. So what I like to do is the square root of 580. So the square root of 580 is about 24. So then I'm looking for two numbers that are roughly close to 24, but notice that I need a 0 at the end for my answer. So I'm going to try, well, maybe one of the numbers is 20, and maybe one of the numbers is 29. So then I try 20 times 29, and I see, wow, it's 580. So just using some number sense, you can kind of come up with that little trick of square rooting. I kind of like that. So then I get 3 times n plus, let's see, it's going to need to be a positive 29 and a negative 20 in order to have it work out with a positive sum. So then that means if n plus 29 is 0, that n would be negative 29. And here if n minus 20 is 0, then n equals 20. And you can't have negative rows. So our answer is 20. So that means the architect needs to have 20 rows. And that would be our answer. Okay, the next one I want to talk about is on number 78, and it's talking about something called arithmetic means. And hopefully you know what a mean is. It's just an average of two numbers. So we do have something called arithmetic means dealing with an arithmetic sequence. And so what that means is you basically are splitting the difference in between into equal intervals. So I'm going to show you by example. You can kind of read the mathematical symbols there. But for part A, we are asked to insert two arithmetic means between 10 and 18. So that means I need to come up with two numbers that are going to be equal distance if I split this. So one way to think about this is to kind of think slope. Remember that arithmetic sequences are linear in pattern. So think about slope. This 10 is a sub 1. This 18 is a sub n. So if I'm thinking about the slope, I would be taking the change in a sub n over the change in n. So I'm going to look at 18 minus 10 over, this would be, I'm sorry, I called this a sub n, but we can specifically call it a sub 4. And then this would be 4 minus 1. So I get 8/3. So that means that's going to be my common difference I would have to use in order to have this work. So I can go 10 plus 8/3. And I get, that's 12 2/3. And then I'm going to add 8/3 again. And I get 15 1/3. And then if I add 8/3 again, I need to make sure I get 18, and I do. So we're good on that one. Part B, insert 3 arithmetic means between 10 and 18. So this time we need 3 of them. So then when I work this out, this is a sub 1, 2, 3, 4, 5. This is a sub 5. So we're going to have 18 minus 10 over 5 minus 1. So we get 8/4, which is 2. So that means if I add 2, I get 12. Add 2, I get 14. Add 2, I get 16. So that one was easier. And then for part C, I know when I extend the page it's going to make it skinnier, but hopefully you can still see that. Suppose a doctor needs to increase a patient's dosage of a certain medicine from 100 milligrams to 300 milligrams per day in 5 equal steps. How many arithmetic means must be inserted? Well, to figure that out, I actually kind of draw it out with my little lines there. So here would be 1 increase, 2 increase, 3 increases, 4 increases, and then the 5th increase needs to be our 300. So that would be 5 equal steps. So notice that first answer would be I had to insert 4 arithmetic means in order to get it to be 5 equal steps. So this is a sub 1. This is a sub 6. So I'm going to have 300 minus 100 over 6 minus 1. So we have 200 over 5, which is 40. So we would want to increase it in 40 milligram dosages. So this would be 140, and then we would add 40 more, and we would get 180, and then we would have 220, and then we would have 260, and then notice if I add 40, I get 300. So that should help you with some examples of application problems. You have an assignment to work on. And remember, sometimes you have to go back and look at the arithmetic sequence formulas to help you get a piece of information that you might need to use in an arithmetic series formula. Sometimes that happens. So do your best on these.